Hello everyone, I'm Xiao Gang. In this lesson, we start the most essential part to do this split tick, and our current condition is that we have already entered this search state. Because we are here, it is here. Let's check if our state has been properly changed. Here, after our state is properly changed, we enter this search direct sender state. After entering this state at the same time, there will be an element in our number. So has this state been properly changed? This is our parent folder, right? Then the next thing we need to do is actually quite clear. In the tick, we continuously repeat, iteratively execute, but we cannot finish executing it all at once. We take one each time and split it apart. That is, we first break a big task into 1,000 small tasks. Then for these 1,000 small tasks, we go through them one by one, by one, by one, by one. This way, we won't get stuck like that in each frame. So obviously, we need to make a simple distinction for this state. So here, we make a simple switch. Okay, so in idle, we are doing nothing. Then we are in what we need to do. Actually, we only need to do work during this phase. This part is very Jackson. Work will be done in these 4 phases. So what work is done in these 4 phases? Actually, for convenience, we didn't write all the code into this tick because this one function is already over 100 lines. If we wrote everything here, this one function would be 500 lines. We can't even maintain code like that ourselves, to be honest, because you have 500 lines. You simply don't know which variables come from where. You can see. So now let's move into our first phase. Then, how do we do it? So entering this phase, when we tick, it will execute this function, right? After entering, what we need to do, actually, let's write this comment for everyone. That is, we mainly call, we will take this. We will take the path in the first number, remove it, then add the corresponding file to the 30 base files file. So how do we do it? First, this file, it definitely cannot be equal to 0. If it is equal to 0, it means this phase is complete, right? Then if it is equal to 0, we change this state to the search fail phase. Then this log, we print a log that we are currently starting to search fail. Then we print log it. Okay, then at this point, we record our time. Then we basically just repart it. We won't play this tick. We'll wait until the next tick to come in. Because on the next tick, it won't go through CDX. It will go down here. Okay, so if there is something in here, then we start to take something out. Because it is not equal to 0, there must be something there. So first we take this first path, right? Then after we take it, we remove it. This part is written a bit silly and cute. If you have seen it, you should have carefully noticed our TRR. I think this writing style is a bit silly and cute, but it's not a problem. Let's first extract the first element, then remove the first element, right? You can see, then at this point, we prepare a host. Then under this folder, we go find this file. So we need to find this file. You can see this function will return this result back to our host. And here there are several Boolean values. That is whether to include this folder and whether to include this file. Obviously, here we should be looking for this folder. Yes, we should be looking for this folder. We can take a look later. And then here we insert it into our search direction. And why do we insert it this way here? You can see we're doing it like this. We insert this element. It is assembled like this. Yes, because this part needs to be assembled, because this path is established under that path. After assembling, we insert it into this position. Yes. After inserting it into position, we then look for this file. Yes. Let's find our current one. That is, we first locate this folder. Then we assemble the folder path and put it back into this array. Interesting, isn't it? So in this folder, I also have subfolders. We just put it in. Then at this point, we look for this file again. We only look for files in the current folder. Then these are the files we found. Then at this point, we assemble this path. The slash is not the division slash. It's an overload. It will assemble the path string. So we splice it in here, right? After splicing it in, add it to our search file list. Then this search file list is what we need to process later. Okay, so in this way, we have completed the processing of one folder. Alright, so let's prepare a log here. Then we'll have it print to display. You can see it here. This log shows that we have which file has been added, the count within this file. That is, we look under this folder. How many folders we find, how many files we find. Actually, at this point you might be a bit confused, right? So let me demonstrate it for you now, and it will be very clear. Let's do it on the desktop. We have a test. Test. Let's replace these files. Let's switch to A1. Let's switch to A1. Then I'll prepare a few files like this. A2, A3, OK. Then let's prepare a folder here. We'll call it F1. Then here, we paste it in. Then we'll rename it here. Let's change it to B. Let's look at A. Let's change it to this name. Then in the folder here, below, let's add another folder. Let's name it E. Let's give it this name again. Let's change it to C. Okay. Then here we can add another layer G. And inside here, we give it a G. Okay, now we haven't written anything right. Good, this one is more complex. Now let's start it. When it finishes executing, it will stop at the next stage. And then at the next stage, it will get stuck here. We'll just let it stop here. We'll iterate through it. Then after we enter, currently it is definitely not equal to 0 because we have this path. So we copy out the first element. Obviously it's this one. Then our path becomes 0. At this point, we first traverse it because we found two folders. These two folders are these two. Then we insert it. You can see the way we insert it here. It should be inserted in reverse order. Why reverse order? It's because I want it to look nicer. I want it to be written one after another. So we make it look nice. See, inserting it like this, it becomes 1, 1, 1, F1. So it's the same as this. If you don't go and plug this F1 into it, then we've put all the folders in. You can see, take a look. It probably isn't that one. It should be this one. Then at this point, we go find the files under the actual folder. You can find a 1AR3, and that's it. Then at this point, we add this thing to our array. You can see it's been added. So we log a message, and here we look at it like this. We can't see it this way. So we'll move it over there. Okay, then at this point it comes again, right? So at this point, the folder it traverses is actually our 11. Can you imagine what is inside 11? Because there are G and C1, C2. Then at this point, it will find another G and add it in, right? This input is still quite clear. It's just like this. It's a bit recursive in nature. Let's move it over. At this point, okay, let's take a look, shall we? You will notice our parent folder. Then we go. By deviating from this path, we add two folders. They are E and F1, right? Then add 3 files. And there are these 3 files, no problem. Next, these 3 files. Next, still process this path. And when processing this path, it adds a folder. This folder is G. Then add 3 more files. These 3 files are its 3 brothers, right? Then what does it process next? It processes this G folder. You see, it goes in order. It goes in order. And here a file was added. That is the G file. No problem at all. Next, process the F folder. F is this level. Then 3 more files are added. You see, it goes in order. It looks very pleasing. Right. Okay. So at this point, it starts searching for files because we didn't write the search file. So in this part, we really... Next, continue writing. Okay. Good. Let's go back here. Next, we will write this. Design the fail phase. We will write it in the next class.